Hey everyone, and welcome to Intro to AI and Machine Learning by me, Arnav J. I will be walking you through this course today. And a little about me, I am a junior at high school in Spring, Texas, and I love playing tennis and I play for my school team. I also love listening to music and playing music. And I also like programming in a lot of different languages, and so I'm excited to share my knowledge of machine learning with you guys. So in this course, we're going to be learning about the exciting field of artificial intelligence and machine learning and how to code for it, creating your own code for it. And in this lesson specifically, we're going to be learning about how machine learning works, the difference between machine learning and regular programming, the different types of machine learning, and the importance and use of machine learning in the real world. So first of all, what is machine learning? And for most of you, this is probably like a really either complicated or stressful topic. So just to get it started off, let's start with a game. So in the next few slides, just try to tell what the picture is representing, either a car, motorcycle, or bicycle. Okay, so here we go. First one, is it a car, motorcycle, or bicycle? Obviously, it's a car. Next one, is it a car, motorcycle, or bicycle? It's a motorcycle, yeah. And the next one, it's a car. The next one, it's a motorcycle. So, how did you find the game? You probably found this really easy because you've seen these vehicles daily, day in, day out throughout your life. And you were able to tell the difference between these vehicles. You had know that what makes what vehicle, what's part of what vehicle, the different attributes that make up these vehicles. But how would you train a computer to understand the difference between these vehicles? Well, this turns out to be very difficult because all cars and motorcycles and bicycles are different. They all have different shapes, sizes, colors. For example, like a sports car and SUV look very different, but they're both classified as cars. You also have to consider that the computer has no idea what any of these vehicles are because it's never seen them before. So if you're trying to train a computer to tell the difference between these with regular programming, it would take thousands upon thousands of lines of code because you'd have to train the computer to recognize each and every type of car, bicycle, and motorcycle, regardless of its shape, size, or color. And this is just to tell the difference between these three vehicles. If I gave you a new problem or any new thing to compare, you'd have to start all over again. So how do we solve this problem? Well, this is where machine learning comes in. So machine learning is the process by which a computer compares data in order to find patterns within that data. Okay, and for example, if we were trying to solve our problem with the cars, motorcycles, and bicycles, we would feed in these pictures to the computer, and we would give them labels accordingly so that the data is already classified into cars, motorcycles, and bicycles. And then we would make the computer try to tell the patterns within these data sets. So what makes a car a car? What features does a car have that the other two groups don't have? So now we're going to learn about a few key terms that you're going to need to know later on. The first one is training data, and this is the data that we give to the computer, and this is the data that the computer learns from. So in our case, the training data would be the pictures of the vehicles that we looked at earlier. And the next term is training phase, and this is the phase in which the computer learns from the data that we give it, and it looks for the patterns and recognizes the patterns within this data. So next up, we're going to learn about how machine learning works. And to do this, we're first going to compare machine learning to regular programming. So as mentioned previously, machine learning consists of trying to find the rules or patterns within a set of data, and then learn from these patterns to find the answers to any new data that we receive. And this is different from traditional programming where you code the rules for the data yourselves to output answers. So in our case, this would be like trying to code for each and every type of motorcycle, car, or bicycle. And this would just take thousands upon thousands of lines of code. Instead, in machine learning, what we're doing is we're just feeding the pictures of the vehicles to the machine, and the machine is trying to find these patterns and these rules by itself so that we don't have to code for it. So how do machines do this? So in order to do this, the programmer typically implements a classifier. And a classifier is a model to classify and compute the data that is given by a programmer. And the one that we're going to use is called a neural network. So a neural network is loosely based on the functioning of a human brain, and it consists of many different neurons or nodes that are all interconnected, and these nodes are placed in several layers. So as you can see here, we have the input layer, you can have one or more hidden layers, and the output layer at the very end. So each layer consists of a different level of mathematical processing, and then the machine then improves on this processing to improve the network itself, and it then learns from its errors during the training phase to provide better answers to the output layer. So the different types of machine learning that we're going to learn today are supervised, unsupervised, and reinforcement learning. And these are just three main types of machine learning, but there are of course many, many more. So first of all, supervised learning. Supervised learning is the most common form of machine learning. It's the type that we used earlier in an example of cars, motorcycles, and bicycles. So supervised learning has the data labeled already, which is given to the computer, and it tells the machine what patterns to look for within these different categories. For example, in our example, we had the computer had the data categorized based on cars, motorcycles, and bicycles, and the computer then learned from these different categories. And next up we have unsupervised learning. So in unsupervised learning is a bit different. The computer simply receives input data without any labels. So in other words, the data received isn't classified into categories, so the machine has to find its own different categories and patterns. So this is especially important in anomaly detection, such as fraud detection, because the machine finds suspicious data within a system which does not seem consistent with the rest of the data, and this is then identified as a fraud. So next up we have reinforcement learning. And reinforcement learning is one of the newer approaches towards machine learning. And in reinforcement learning, the programmer provides the machine with a set of data and then lets the machine categorize or work with the data based on a trial and error method. So if the machine's results are favorable, it receives a reward. Otherwise, it receives a penalty. And then it then uses these rewards and penalties to decide and look at better answers. And then it goes from just complete guesses to doing what the programmer intends for it to do almost every single time. So now we're going to move on to applying machine learning to code. Now, before we get started, there's a few things I wanted to mention. First of all, for those of you who have very little experience in coding, there may be something about this code that you won't understand, and that is completely fine because we will go through the code line by line later on. And the following program is encoded in Python and uses the TensorFlow open source library, and the code is based on the Learn TensorFlow 1 lab on Code Labs and is really great for beginners. If you want to test out the code yourself, here's the link for it. You can use the free Google Colab service, and here's the link for it. And otherwise, you could just search up Google Colab and click on the first link that pops up. So this is the code right here, and yeah, so as I said before, there may be some things that you don't understand with this code, and that's completely fine because we'll go over it line by line later on. Basically, all we're trying to do is get you to understand the basics of this code, just what it's trying to do, so that later on you can code for something similar to this or even more complicated. So this code basically just takes in two sets of values and tries to find the correlation between these values. So what function makes the first set of values into the second set of values? So the first three lines of code basically just import the different libraries that we need, the TensorFlow, NumPy, and Keras from TensorFlow libraries. They will help us with array creation, machine learning algorithms, etc. So the next two lines just create the two arrays, or that's two sets of data that we're going to compare. So you see there's an X set, which is denoted by XS, and the Y set, which is denoted by YS. So can you find the pattern between the X and Y data? So the pattern is actually every Y value is equal to the corresponding X value times 2 minus 1. So basically what this means is, if you see the first X value is -1. So -1 times 2 is -2, minus 1 is -3, which is the first Y value. And this holds true for each of the values in both the X and Y lists. So the next thing we're going to look at is this line of code here. And this is the line of the code that creates the neural network for our program. But this neural network is very simple. It only has one layer with one neuron, and it also has one input. So all we're trying to do here is just trying to get one input, which is the x value, and try to get the computer to process it and come up with the output, which is the y value. So now we're going to look at this line of code. So this line is very important because it's the line that takes care of the entire decision-making process within the code. So when the code is running, the loss function, which is the function in red here, calculates how wrong the machine's guesses are, or the machine's predictions are, by comparing them to the correct answer, or the y values in the array that we defined before. Meanwhile, the optimizer function in green then uses this data from the loss function and then uses it to try to make a better guess, like uses it for the computer to try to make a better guess or a better prediction as to what the y value is going to be. So by doing this repeatedly, the machine slowly starts to get better and slowly starts to learn the better or more correct answer, and it slowly starts to get closer to the correct answer or the y value of the answer. So moving on. Now we're going to look at this layer here, the model.fit line. So this line runs through the optimizer and loss function 500 times, which is in the light blue area over here. So you can adjust this number to how many ever times you want it to run. And the more times you run through the optimizer and loss function, the more accurate your answer is going to be, because the more accurate the computer is going to get at predicting the answer. So now moving on, these are the last two lines of the code, and this feeds in a new x value. So here in the pink here, this feeds in a new x value, which is 10, and tries to get the computer to predict the y value for it. So this is where we're actually testing out the code and testing out the learning of the machine. So the line before just creates a new line to create a bit of space from the running data, and you can change this value to enter in any new x value that you want. Okay, so now finally you may have noticed that the number that we gave the computer at the end of the code was 10, and 10 times 2 minus 1 is 19. However, the computer predicts a number that is not exactly 19, but very close to 19. This is because we only gave the machine 6 numbers to work with, or 6 sets of numbers to work with, as training samples. And although we know that the correlation between the input and output is 19, the machine cannot be 100% sure of this because it is receiving new data input only after having 6 samples to work with. This is like if you're just introducing a new math concept and you're only given a few problems for that concept. You might start to understand it, but to be 100% sure of getting every single question on the test right, you would have to go through and practice many, many problems till you finally mastered that topic. So for this reason, it's very important to provide the machine with a large set of training data in order to be as accurate as possible. So now we're going to move on to the applications of machine learning in the real world. So some examples of machine learning in the real world are image recognition, face recognition, virtual assistants such as Google Home, Amazon Alexa, and self-driving cars, and speech recognition. And many of these things are things that we use in our daily lives, and it is also used to drive newly developing technology that is coming up in the future. So as you can see, machine learning is not only widely used by large companies and corporations, but instances of it can also be found around the house or in your daily life. It is used worldwide to solve the complex problems that we ourselves would take years and years to solve. And because of this, technology around the world is growing at a rapid pace, from cameras that can recognize multiple faces in a crowd to cars that won't even need to be driven by us. So machine learning has great promise from the future and has the potential to revolutionize the future of technology. So here are some links that I found really helpful. The first one is this one, Intro to AI, and it provides a really good context of AI in the real world. And to find that, just search up Intro to AI Snips, and it should be the first thing that pops up. The second one is a video explanation of a similar code, and to find that, just search up Intro to Machine Learning TensorFlow, and should be the first video link that pops up, or you can just search this up on YouTube. And finally is the Google Colab link once again, and you can just search up Google Colab, and it provides a place for you to test out all your Python code, including the one that we used today. So thank you for watching this video. If you have any questions, you can email me at arno04.ajay@gmail.com. And yeah, thanks for watching.